For this lesson, we're going to learn to write arithmetic sequences as an equation. So we have a sequence right here. Remember, arithmetic sequences work just like linear functions. So we're going to use what we knew before, y equals mx plus b in slope-intercept form. Find the slope, find our y-intercept, and then we'll be good to go to write an equation for it. So to start off, I'm going to take this sequence, I'm going to write it in a table of values so we can relate it to our linear functions. We have to remember that this 13 is our first term. 26 is number 2, and then third, then fourth, and so forth. So we can write that now as a table of values. That would be 1, 13, 2, 26, 3, 39, 4, 52, and we could keep going if we wish. This table will allow us to find our slope. So the y, the change in the y, is our rise. That would be plus 13 for each of these, plus 13, plus 13. The change in x is our run. In this case, it's plus 1, so plus 1, plus 1, plus 1. Written as rise over run, we get 13 over 1. Our rise and our run. You're welcome to graph this if that would help you to visualize that. Looking at the sequence right here, we can see that 13 show up in the pattern where we add 13. 13 divided by 1 is just 13, so we can get the slope either way. All right, let's take that and put it in over here. We get y equals, that would be 13x. We need to find our y-intercept. So we have one extra step to do on this one because we do not have our y-intercept. We've got to go back to step 0. So if we take this back one step, subtract 13 to go backwards, would put us at 0. Our y-intercept would be plus 0, which in this case we don't need. So I'm going to rewrite it as y equals 13x, and that's our equation. We're going to change this to have sequence notation though, so we can write this slightly differently. The only two changes we need to make is that our x value has been switched out to n, representing a natural number, and our y value has been switched out for a sub n. We're going to make those two changes here. We do a sub n equals 13 times n. Now we're going to do one more step on this. I'm going to ask you to calculate a value for a step. So let's calculate for step 10 in this case. That means we're just going to replace n with a 10 because n stands for the step number. So that would be a sub 10 equals 13 times 10, and 13 times 10 is just 130. So a sub 10 equals 130. Let's try it on another one. This time I'm going to try to do it without writing a table of values. We can see the pattern right here is subtract 3, and if you recall from the last one, that gives us our slope. So we have y equals mx plus b. Our slope now we know is y equals negative 3x. We need our y-intercept. Remember, this is step 1. I've got to go back to step 0, so let's go back one step by adding 3, reversing that pattern, and that will give us negative 3. So y equals negative 3x minus 3. Changing this to sequence notation, our y has been replaced with a sub n, and our x has been replaced with n, and we're done with our equation. Let's calculate for step 7. That would give us a sub 7 equals negative 3 times 7 minus 3, or a sub 7 equals negative 21 minus 3. A sub 7 equals negative 24. So we're done with our calculations, and that finishes up the step number. I do want to go through one more example that you will see in the homework. It involves some pictures. So take a look here at these pictures of smiley faces. You'll notice that the first picture has 4 smiley faces, the next picture has 6, 8, and 10, and the pattern continues in the same way, so you could probably figure out how to draw the next step, would have 12. And you will notice that if we write those as a sequence, 4, 6, 8, and 10, the pattern is that we are increasing by a value of 2 each time. So we can take that, use it as our slope. That would give us, and we're going to skip straight to sequence notation this time, a sub n equals 2n. We still need our y-intercept. So let's take it back one step and figure out that there would be 2 smiley faces for step 0. That would give us our y-intercept of 2. So a sub n equals 2n plus 2. We could then use that to calculate future steps of how many smiley faces if we wish. Thank you very much.